Awesome. Great. So vector very important, really for everything that we have to do in this class, because direction is really, really important. Direction matters when we're trying to add different quantities. Okay. So a vector is very general. In the most simplest form, a vector is something that has a magnitude and a direction. Okay. That's simple. Right, there are two things. We got scalars, vectors. Scalars don't have a direction; they just have a magnitude. Magnitude is a number. Right, vectors have a magnitude and a direction. Okay, and those directions are very important when it comes to putting things together. Okay, examples of vectors would be velocity, right, acceleration, force, all right, momentum. All right, those are all different vectors that you can deal with. Okay, so we're going to see a lot of them, and you're going to have to take a lot of those into account. And we kind of have already when we talk about maybe like gravity with acceleration pulling things down as opposed to going other directions. Okay, so the first way we usually start is how can we add them? All right, and the first way that you can add a vector is really what they call graphically. I don't want it to go that way. Let's say I have a couple vectors. Actually, let's start with this nice. When I've got one that goes like this, I want it to... all right, that looks about horizontal, right? And then I've got another one that goes something like this. Now, from your reading, you guys all have a pretty good idea of what it should look like, right? What the resultant should look like, but bear with me here, okay? We've got two vectors here. We've got, let's call this vector A, vector B, and I want to know what is the result. Right? What do I get when I add them together? Okay? So the quick and simple way is we draw them first, we draw them tip to tail, and then the result is if we go from where we started to where we finished. Oh, don't do that to me. All right. So that would be our result, and we would give them these notations. So vector A would have that, vector B would be this vertical one, and then so our result would be this simple one that goes across like this. Okay? And we can do that for any vector. Right? So if we've got a vector that goes like this, and then a vector that gets added like that, if I want to know what the result is of these two vectors right here, again, I just go from where I started to where I ended. All right, it's going to be in that direction. So this would be my result again. Okay, pretty simple. Makes sense? Okay. So when we're drawing them, that's cool. That's easy. But let's say they're in, when they're perpendicular, pretty simple. When you're going to draw them out, pretty simple. But let's say I've got numbers now. All right, and I actually know what the magnitude of this is, and I actually know what the angle that it's traveling at is. All right. I can break them up into these things called components. The components are actually really simple, and they're really useful. And we're going to now show you why you can go tip to tail the way we did. So why can I just go from these two to this? And it's pretty simple. All right. Let's start with a vector like this. Oops. And then a vector like that. Okay? So I've got these two different vectors, and we can call them vector Q and vector P. Okay? And I want to know what is the resultant. So what I can do, these not necessarily easy to add. If I want to know what this plus this is, talking about numbers, they're not necessarily the easiest thing to add. So what I want to do is I want to break them up into things that are parallel and perpendicular. Because if they're parallel and they're pointing in the same direction, we can add them very simply, right? Their magnitudes. If they're going in opposite directions like this, we subtract them, right? And if they're going perpendicular, right, they make a right triangle. So to find the value of the hypotenuse, it's just the Pythagorean theorem. Okay? Pretty simple. These are parallel or perpendicular. But we can make them that way. We can force them into parallel and perpendicular. Okay? And the way we do that is with these things called components. All right? Components are pieces of a vector that when you put them together, make your original vector. It's like the Lego pieces that make a whole thing, right? So if you have like a building, this would be your building, and the components would be the little Lego blocks that actually make the building, okay? So you always have two components. You have one component, which is your x component, that runs along the x-axis. Maybe it goes like that, okay? And then you have your y component, which goes along the y-axis like this. And we could call them q sub x and q sub y, right? So this is the x component of vector q. This is the y component of vector q. Okay? Everybody's good there? And then we do the same thing for p. Actually, it might be easier to do it this way. Oops, wrong tool. I don't want that color, though. So we've got this one, and then we have like this. And we would call this one p sub y and p sub x. Okay? So what we're going to do now is we have kind of the pieces, we have the start of like parallel and perpendicular, not quite there yet. If you remember back to the activity you did with the vector walk, right? What's cool about vectors? Yeah, you can put them in any order you want, you're going to get the same result out, right? So that's what we're going to do here. I'm going to take what I've got right here, and I'm going to rearrange the order so that I make them parallel and perpendicular. Okay? So what I'm going to do is I'm going to take this guy right here, and I'm going to put him right there. Okay? He doesn't look very straight, but that's all right. And then I'm going to take this guy right here, and I'm going to make him parallel, these two parallel to each other, correct? Yeah. That's okay, right? That's doable, that's allowed? Yeah. And then I'm going to take this one right here, and that one right here. Okay? So now I've made them all parallel and perpendicular. So that if I take this one, right, we'll just make them this lovely color here. My resultant should look something like that, right? That's the result when I add them. If I take these over here now, they should fit pretty nicely. Okay? So all we're doing when we're dealing with components is we're taking the components of each piece of each vector, and we're rearranging them so that they're parallel and perpendicular. Okay? That's why this works, is because we're taking these and we're breaking them up and making our own new triangle. Yeah, Henry?
Do you still call the blue one R?
This is still the resultant, yes. This is still the resultant R. Okay? Yeah?
Mr. Flatt, in the book it said you just have to add like Q and P, but instead of just finding the hypotenuse, so it doesn't like...
The adding is this.
Okay.
So you would write this as Q plus P.
But that's still the hypotenuse, right?
Yeah, that is still the resultant of this guy right here. Yeah, the hypotenuse of this triangle that the components make. Okay? So now, this is really simple. This won't take more than a second. You've got this vector right here. You've got this vector Q right here, okay? I want to know what are the actual numbers for it, because we can find those numbers, okay? This triangle here, he makes, right, we've got a component right here. If this was Q, we've got a Q sub X, and we have a Q sub Y, okay? He makes some angle theta, right? Between, if this is the x-axis, he makes some sort of angle there. Correct? Everybody's good? Okay? So I want to know what Q sub X is. So if we look at what we know the hypotenuse and we know the angle. Okay? And this is the adjacent side, right? Q sub X is the adjacent side. So I know the hypotenuse, adjacent, we're going to use cosine, right? So this would be Q cosine theta. Going the same way, using the same thoughts, this is the hypotenuse Q. This is the opposite side. Right, it's going to be Q sine theta. Okay, so it's the magnitude of whatever this is. So if this has a magnitude of 25, right, let's say this is a force, right? So let's say it has a magnitude of 25 newtons. You would plug in 25 for the Q times the sine of whatever the angle is. Very important, make sure that your calculator is in degrees. All right? Your calculator needs to be in degrees. Okay? Does this make sense? Pretty simple? This isn't too tough.